Welcome to PyMath. In this video, let's look at arriving some of the sum to product trigonometric identities. Before we get to that, some of the prerequisite trigonometric identities that you should be already knowing is shown there. Sin A plus B equal to sin A cos B plus cos A sin B. Let's call it as equation number 1. Sin A minus B equal to sin A cos B minus cos A sin B. Let's call it as equation number 2. Cos A plus B equal to cos A cos B minus sin A sin B. Let's call it as equation number 3. And cos A minus B equal to cos A cos B plus sin A sin B. Let's call it as equation number 4. So in another video, we arrived at this product to some trigonometric identities, which you should be already knowing. Let's call the first one, which is 2 sin A cos B equal to sin A plus B plus sin A minus B. Let's call it as equation number 5. 2 cos A sin B equal to sin A plus B minus sin A minus B. Let's call it as equation number 6. And 2 cos A cos B equal to cos A plus B plus cos A minus B. Let's call it as equation number 7. And these two, the last two, are the same, except how we want to see. You want to see minus 2 sin A cos sin B or just the 2 sin A sin B. So if you want to carry the minus inside to the right hand side, so we swap it. So we get to the last one, which is cos A minus B minus cos A plus B will give you 2 sin A sin B. So let's call them both as equation number 8. So now let's see how we can arrive at some of the sum to product trigonometric identities. Before we get to that, let's assume C as A plus B and D as A minus B. We are introducing the new variables C and D just because we want to have the A plus B shown as C and A minus B shown as D and arrive at this sum to product. So if you add the C and D, you will get 2A. So thus A equal to C plus D by 2 and B equal to C minus D by 2. As if you add the C and D, you will get 2 A's, but when you subtract, you will get 2 B's, and that's why it's B as C minus D by 2. So let's remember this set of the relationship between A, B, C, and D, and let's put them into equation 5 to 8. So let's take up this right hand side portion of these identities and let's write them first, which is sin. For equation number 5, we are looking at sin C plus sin D equal to 2 sin C plus D by 2 cos C minus D by 2. This is a new identity that we arrived at just now. Let's call it as equation number 9. Let's get to the identity number 6. Let's take up the right hand side first. Sin C minus sin D equal to 2 cos C plus D by 2 and then sin B, which is C minus D by 2. So we are arriving at a new set of trigonometric identity, which is identity number 10. Let's get to identity number 7. So cos C plus cos D equal to 2 cos C plus D by 2 cos c minus d by 2. So we are arriving at the new trigonometric identity, which we called as 11 here, but cos c plus cos d equal to 2 cos c plus d by 2 cos c minus d by 2. Let's take up the identity number 8, which is the trickiest one. So let's get to the right hand side first, so which is cos c minus cos d equal to minus 2 sine c plus d by 2 sine c minus d by 2. So the last one, which is shown here, where we don't want to see this minus here, so that's cos c cos d minus cos c equal to 2 sine c plus d by 2 sine c minus d by 2. This is also another way of looking at the same identity, so let's call this both as identity number 12. So cos c minus cos d equal to minus 2 sine c plus d by 2 sine c minus d by 2. Let's say I don't want to see this minus here, so I want to carry this inside. Is it possible? Yes, because if you look at a sine minus sine theta, can I write it as sine of minus theta? Yes, you can, because let's say this is a theta, and if you have minus theta, which is in the fourth quadrant, sine of minus theta equal to minus sine theta. So thus, if I carry this minus on this equation number 8 into the sign here, I can write cos c minus cos d equal to 2 sine c plus d by 2 sine, I'm carrying this minus into inside of the sine c minus d by 2, so thus I will get d minus c by 2. So this is also another way of writing same identity. So let's call this one 2 as identity number 12. So these are some of the interesting and useful sum to product trigonometric identities. If you like the video, please subscribe. Thank you for watching.